Good afternoon, guys. In this lesson, I'm going to explain to you the concept of compound interest, which is just another way to charge interest, different from the simple interest scheme. And so let's take a look at how this works. So what is compound interest? Compound interest is the scheme or the way of charging interest not only on the principal, but on previously generated interest as well. So let's see how this works. If you remember the exercise that we did last time, we were considering two quantities or two variables, right? One variable of time, and we're gonna measure that in years. And I'm gonna mark year 0, 1, 2, 3, and any general year t. And then the accumulated amount of money, and this is in units of currency, right? So for compound interest, this works in the following way. The accumulated amount at time 0 will obviously be the principal, right? Which is when the loan takes place. Then 1 year goes by and the accumulated amount is going to be what you had previously, which is P, the principal, plus the generated interest from year 0 to year 1. The generated interest, right? How do we charge interest? We take the rate and we multiply it by the principal. So this is the interest, right? Then I can algebraically do the following. I have a P as a common factor, and we have this. Okay, so that is the accumulated amount at year 1. So far, it's basically the same as with simple interest. But now you're gonna see something different when we move from year 1 to year 2. Another year goes by, and the accumulated amount is gonna be equal to the previous accumulated amount, which is this much. So I need to put it once again in here, right? Plus the interest generated from year 1 to year 2. I'm gonna have to put in here the newly generated interest. Now, the difference, guys, of compound interest with simple interest is that this newly generated interest won't have or won't be calculated using only the principal. It will be calculated using the previous accumulated amount, which was this. Okay, so basically I'm gonna be applying the rate of interest, which is R, to this previous quantity, not this one. You see what I mean? Okay. Now, can we do some algebra here? Yeah, we can, because if you notice, this term and this term have a common factor, which is P times 1 plus R. All of this is actually a common factor, so I'm going to take it out. And if you factorize, you're going to get that this multiplies 1 plus R. Please make sure to understand that part. Okay, if I take this and multiply by 1, I get this one. And if I get this and multiply by R, I get this other term. So this is in fact the correct factorization. And I can express this multiplication as this. There you go, right? Okay. And I guess you can see the pattern right away. The accumulated amount at year 1 is P times 1 plus R to the 1. The accumulated amount at year 2 is P times 1 plus R to the 2. And it's going to be the same for year number 3. You know, I don't need to do the whole algebra because, first of all, it's not going to fit in here. So let's skip it and let's go directly to the simplification. You're going to get this, and therefore you can induce the general formula, right? For any general year t, the accumulated amount is going to be equal to the principal times 1 plus the rate of interest to the t. What is t? Is the time measured in years. What is r? The rate of interest. expressed as a decimal. And what is P? The principal. And what is A? The accumulated amount at any given point in time. So now this is going to be the formula, guys, that we're going to be using for compound interest. It's this one. And now let's put it to use. Example number 1. Fernanda puts $3,000 on a savings account that pays 5% compound interest per year. Find question A, how much will be in the account after 3 years? And B, what was the interest generated in those years? Let me be more specific. In those 3 years. So, okay, I'm dealing with compound interest. And the formula that we have discovered from the previous slide is this one. Okay, so let's answer question A. How much will be in the account after 3 years? So first, let's find out how many quantities I can get out of reading the statement of my problem. This is clearly the principal. This is the rate of interest, R, 5%, but remember, you should always put this in decimals, 0.05. And also from the letter A statement or line of text, we get that the time is 3 years. Time is 3. So basically, we have everything to calculate the accumulated amount, okay, which is basically how much there will be in the account after 3 years. So let's find out. A will be equal to 3,000 times 1 plus 0.05 to the 3. And that's it. That's my solution, right? This is a perfectly good response. Try to simplify, though, if you can. I mean, if you find any calculator over there, I'm using mine. And we will have this much. There will be this much in the account, $3,472.88 after 3 years. So this is the answer to letter A. Now letter B, what was the interest generated in those 3 years? Okay, this is a simple question. What is the interest generated during those years? Well, the interest is clearly the difference between the principal minus, the interest in this case will be the accumulated amount minus the principal, right? What is accumulated amount? It's this much. And the principal is known to be 3,000. So it's going to be 472.88 dollars in this case. So this is how much extra Fernanda won or gained by having her money on a savings account that pays this percentage of compound interest per year. So that is example number 1. Now example number 2, Carlos took out a loan of $12,000 for his college tuition. We know that the interest paid was compound. So there you go again. We were talking about compound interest. And that he has to pay $14,500 in 3 years. Find the interest rate of this loan. So once again, this is the formula that relates all of the quantities involved in compound interest. What is the principal in here? It's 12,000. What is the rate of interest? We don't know. That's what we need to know. What is the time? The time is 3 years. And we actually have the accumulated amount, which is this 14,500. That is how much he has to pay, right? Okay, so you have these three quantities, and you can actually put them in here. There you go. Okay, and as you can see, you have an equation with just one variable, which is r, and therefore we can solve it. You can first work completely in an algebraical way. You have 14,500 over 12,000. That's going to be equal to this. And then you take the cubic root of this fraction. That's going to be equal to 1 plus r. And eventually, r will be equal to the cubic root of this fraction minus 1. So give me a few seconds to calculate that thing, that arithmetic. Once again, please you do it as well. Calculate this amount. And I get a quantity of 1.29, which I think is somehow incorrect. Let me check what am I doing wrong. Let me make a pause because I think I'm doing something wrong here. I found out the mistake. I was doing this incorrectly in the calculator. That's why I got this. This is wrong. And the rate of interest that I got is 0.065. When we convert this to percentage, that's going to be 6.5%. And that is the interest rate for this particular example. So there you go, guys. I think it's enough with these two examples. That's enough for you to understand how compound interest works. I want you to begin already with that section of problems, which is exercise 1L. All of these ones, there are 8 problems, and I want you to have them done for the next lesson. All of these problems are on simple interest and compound interest. And in my opinion, they're not difficult. You're going to be able to do them on your own. So there you go, guys. Thank you so much.